All right, in these problems that have two balanced chemical equations, we solve them exactly the same way as if we just had one balanced chemical equation, except we have two mole-to-mole conversion factors. The first step is to balance each of the equations that were given. All right, so that's what I've done. We have our two balanced chemical equations now. The next step is to identify the chemical that's common to both of these balanced chemical equations. And that chemical here is lithium nitride. We see lithium nitride as a product in the first balanced chemical equation, and it's a reactant in the second balanced chemical equation. Our question statement asks us to compare lithium to ammonia. If we look at our first balanced chemical equation, we see we can relate lithium to our common chemical, lithium nitride, and in the second balanced chemical equation, we can relate lithium nitride to ammonia. So we're going to have two mole-to-mole ratios. Okay, we again go back to the question statement, and this is our measured number. We have so many pounds of ammonia. Now, in order to compare ammonia to our lithium nitride, it has to be done moles to moles. And even though we know the formula weight, we know the formula weight is grams per mole, so we're going to have to convert pounds to grams and then grams to moles. We may have to go back to our conversion sheet to remind ourselves of the conversion factor between pounds and grams. We know that we've set up this conversion factor correctly because the unit of pound cancels out and we end up with the units of grams. Now to go from grams per mole, we remind ourselves of the formula weight of ammonia, and we know that 17.04 grams is equivalent to a mole of ammonia. And again, we know our conversion factor is set up correctly because the units we don't want cancel out, and we end up with the units that we do want, moles of ammonia. We look back to our two balanced chemical equations, and we see here is ammonia, and we want to relate ammonia to the common chemical. The link between these two equations is always going to be the common chemical. So we're going to use the second equation to relate ammonia to lithium nitride. And we see our mole-to-mole ratio is set up correctly because moles of ammonia cancel out and we're left with moles of lithium nitride. Now we look back to our first balanced chemical equation so that we can relate lithium nitride to lithium, which is our ultimate target in this question. And again, when we're setting up our mole-to-mole ratio, we want to pay particular attention to the coefficients that are associated with each of these chemicals. And here's our second mole-to-mole ratio. We look and we see moles of lithium nitride cancel out with moles of lithium nitride. And we were careful to include the coefficient associated with lithium nitride appropriately in our mole-to-mole ratio. Same is true with the lithium. We have our two separate mole-to-mole ratios set up correctly. We can tell that because we end up with moles of lithium. Now we check back with our question to see how the answer is supposed to be expressed. And we see we want our answer in grams of lithium. So we're going to need the atomic weight of lithium to convert between moles and grams. And we see our final conversion factor is set up such that moles of lithium cancel out. The only unit that survives is grams. All right, and we calculate out our final value, and we look back to the problem for sig figs. Here's 3, 5, 4 exact. Our mole-to-mole ratios are not going to impact the sig figs because they're exact numbers. 3 sig figs, we're limited to 3 sig figs, so 262 is our final answer.